Hey everybody, welcome to another video, and today we'll be learning how to find the relative extrema and increasing/decreasing intervals of a function. So, we can have a relative extrema when the derivative of a function is either 0 or undefined. So let's jump straight into an example. So let's say we have f of x is equal to x to the power of 3 minus 3x squared minus 9x plus 1. So in order to find relative extrema and increasing and decreasing intervals, we first have to find the derivative of the function. So using the power rule, we have f prime of x is equal to 3x squared minus 6x minus 9. And now, since we were looking for critical points are candidates for relative extrema. So we can set the first derivative equal to 0. Now we just have to solve for this quadratic, and we can actually take out 3. We can divide each term by 3. So we're going to have x squared minus 2x minus 3 is equal to 0. Now we factor to solve for the quadratic. We're going to have x minus 3 and x plus 1 equal to 0. So our critical points are x is equal to 3 and x is equal to negative 1. So these are critical points. Okay, now that we have this ready, we can actually make a chart with intervals in between these critical points. So the chart will go something like this. Let me move over here. So we're gonna have the interval and the sign of f prime of x. And since this is a polynomial function, we're going to be looking at the intervals from negative infinity to positive infinity. So we're going to have negative infinity to our first critical point, which is negative 1. Then we're going to write negative 1. We're going to do negative 1 to our next critical point, which is 3. We're going to write 3. And then our last interval from 3 to infinity. So these are our intervals where our derivative can be changing signs, which means that the function will be increasing or decreasing. So we know that if we plug in negative 1 and 3, we're going to get 0. And notice how we're plugging these values into the derivative. Okay, now let's plug in a value in between negative infinity and negative 1. We can plug in negative 10. If we plug in negative 10, this bracket is going to be negative and this bracket is going to be negative. So we can plug in 0 into this bracket, which will have negative here and positive here. So the sign will be negative. And now for this one, again, we can choose 10. So this bracket will be positive, this bracket will also be positive. So our final sign of f prime of x will be positive. And now we have to put this in context. So on this interval, the sign of f prime of x is positive. That means that the function is increasing. On this interval, again, the sign of f derivative of x is negative, which means that the function on this interval is decreasing. And again, we have same case on this interval, which means the function is increasing. So now, we found our increasing and decreasing intervals. Now we have to find the relative extrema. So we will have a relative maximum if the sign of f prime of x changes from positive to negative, and we'll have a relative minimum when the sign of f prime of x switches from negative to positive. So here we can see we have sign of f prime of x being positive, and then it switches to negative. So that means at the point where it switches, we're going to have a relative max. And now over here, since our sign of f prime of x switches from decreasing to increasing, we're going to have a relative minimum. Okay. So just to reiterate, whenever our sign of f prime of x is negative, that means our function is increasing. And whenever f prime of x is positive, our function is increasing. And whenever it's negative, it's decreasing. And again, when our sign of f prime of x changes signs from positive to negative, we're going to have a relative maximum. And when it changes from negative to positive, we're going to have a relative minimum. Okay, we can do one more example. Okay, so our next function, f of x is equal to x over x squared plus 1. So first, what we do is we find the derivative using the quotient rule. So we have f prime of x is equal to, we take the derivative of the first term, which is just 1, and multiply it by the bottom. Now we subtract and we keep the function at the top and differentiate the function at the bottom. So it's just 2x. All over the function at the bottom squared. Okay, so now we can simplify. We're gonna have x squared plus 1 minus 2x squared over all of this at the bottom. And if we simplify again, we're gonna get negative x squared plus 1 over x squared plus 1 squared. Okay, and again, our derivative will have critical points whenever the function is either 0 or undefined. So if we want to find where the function is 0, we can set the numerator equal to 0. So we can set negative x squared plus 1 is equal to 0, which we're going to get x squared is equal to 1. And now if we solve for x, we're going to get x is equal to plus or minus 1. So this is our critical, these two are our critical points. Now, we'll have another set of critical points whenever f prime of x is undefined. And in order to find when f prime of x is undefined, we have to look at the denominator and see when it's equal to 0. So we can set x squared plus 1 squared is equal to 0. And if we simplify all this, we're going to get x squared is equal to negative 1. And now we can't solve for x because we're going to get an imaginary number. So actually, we cannot have this. We only have two critical points because we're looking at a real plane. We're not looking at an imaginary plane. Okay. So let me erase this. And now we can do the same thing we did for example 1. We can make a chart with this interval. So we're going to have negative infinity to negative 1, negative 1, negative 1 to 1, 1, 1 to infinity. And we know if we plug in this, we're going to get 0, so we'll put 0 and 0. And now we just have to we just have to plug in numbers in these intervals into our derivative. So we always know that whatever we plug into the denominator is going to be always positive. Okay, we know whatever we plug into the denominator will always be positive. So we're just looking at the numerator, sorry. So if we plug in negative 10, we're going to get negative 10 to the power of 2, which is 100. And it's going to turn negative, so we're going to have negative. And if we plug in 0, we're going to get a positive number. And if we plug in like 10, it's also going to be negative. So we know that our function is going to be decreasing on this interval, decreasing on this interval, and increasing on this interval. And now we have to apply what we learned in example 1 and see how our derivative changes. So our derivative changes sign from negative to positive. That means here we're going to have a relative minimum. And here it's going to change from positive to negative, which means we're going to have a relative maximum. Okay, yeah, so this is it. Remember, whenever our derivative changes signs, that means we might have a relative extrema. And I hope you have a good day, and goodbye.